Welcome to Paul's Passive House. Think you don't have a thermal bridging problem? Think again. Modern day construction is rife with thermal bridging. This leads to the highest percentage of heat loss from any single construction component. 35% of your heat loss is through your walls, and nearly all of that heat loss is due to thermal bridging. That's more heat loss than your windows and doors combined. In these pictures, you can see vertical lines where the ice has melted on the exterior of my walls. Contrast this with a section of the house that I've already insulated. Notice how the morning frost remains, with no melting from thermal heat transfer through the studs. Before we move on, notice how there's still heat transfer occurring at the bottom of this wall. This is likely due to one of two culprits. The first potential source of heat transfer is from the inside of my house. It is possible that I have not yet adequately sealed the bottom sill plate of this wall, or that my slab requires more insulation to stop the inside heat from escaping. The second is that this heat is transferring directly from the ground. Thermal heat from below the frost line is traveling up my foundation, through the wall components, and melting the frost. Either way, I've got to finish the addition on my house so that I can install my heat pump. If you have been following my progress, then you know that up until this point, I have been retrofitting from the inside. I've removed the drywall from the exterior walls and installed wool bats into the stud base, and topped that with 3.5 inches of polyiso rigid foam. That was necessary for the original footprint of this house because originally there was asbestos siding installed and I did not want to disturb it. However, this addition was built without asbestos, so I'm now able to work from the outside, which is much easier and a less intrusive process. This change is especially beneficial for you, the viewer, because by watching my videos, you get to see both processes. Retrofitting from the inside and from the outside. It goes without saying, though, that if you have the option, it is always better to retrofit from the outside. As you progress through this series, you'll see exactly why. Working from the outside is much faster, easier, safer, and more effective. Have you ever wondered what it's like to be obsessed with retrofitting your house to the Passive House standard? Well, imagine waking up every morning, making a strong cup of coffee, and then spending the next hour searching for used building materials online. Best case scenario, you make contact that morning and schedule a time later that day to pick up the material in your truck. Then you get to bring that material home that afternoon, only to be confronted with your next problem: where to put it. You've already filled your attic, garage, extra bedrooms, and you've even filled pallets outside full of insulation, zip sheathing, siding, heat pumps, and anything else you thought you might need. In my addition, I've got wool bats, fiberglass bats, rigid XPS, rigid polyiso, rain screen, framing studs, heat pumps, vinyl flooring, extra heaters, a swamp cooler, HVAC ducts, 2 eco domes, and many of my tools and other building supplies. Outside, I have metal siding, concrete siding, and 3 different types of zip system sheathing. My house is basically a warehouse that is constantly under construction. It has become an obsession. So I've taken the liberty of removing the siding from this is my west wall, and I'm going to have to do the same process to the south wall here and also the north wall. Now, of course, the people that built this addition put windows on the north side, which is the worst place to put windows, and they put a window on the west side, which isn't terrible, but it's not ideal. And you'll see what happens to those windows as we progress through this video. However, before I get started on this wall, it's starting to get chilly here in Denver, and I need to finish my utility room. You can see here that I started by putting down XPS foam insulation 2 inches thick on the floor of my utility room. I also put down 2 framing members. That's pressure treated wood right there. That's going to be the wall. I finished up the first layer of foam with tape and then added another layer of foam, making sure to offset the seams wherever possible. Then it was time to start building the wall. I put in the framing little by little, and then put in OSB subfloor. Initially, I had taped the subfloor, but this tape does not stick to OSB, so it didn't make a lot of sense to try and tape it. Plus, I had taped the 2 XPS foam insulation layers beneath this subfloor, so I'm pretty airtight already. Now, what you're looking at is 4 inches of XPS foam and a subfloor on top of that. Now that my subfloor is in place, it's time to put down the vinyl plank. Now, this is luxury vinyl. It's a rigid core vinyl plank flooring with a cork underlayment. Once the flooring was in place, I could move the appliances back into position. I've got my heat pump water heater, and I just got a new heat pump washer dryer unit. Now, when I say new, that's new to me. It's actually about a year old, and I got it used, but I got a hell of a deal, so it made sense to purchase it. Both units have drip trays at the bottom to collect any water that might drip out of them, although I don't anticipate this being a problem. And as some of you will notice, I still have plumbing to complete in this room, and I'm not going to address that in this particular series. Well, now that all the appliances are in place, I can finish the walls. Here I added studs, 2 feet or 24 inches on center, and a rough opening for a door that I'm not going to install now, but I will install sometime in the future after I find a good, cheap, used door. Or, if everything works out really well, I might install a brand new door. Once the framing is up, then it's time to install the zip system sheathing. Now, this sheathing is 2 inches thick. It's an R sheathing, so it has 1.5 inches of polyiso, and then it has a 1/2 inch of zip. I taped all the seams, including the corners. I left the inside corner because that's going to take a special tape job that I was not prepared to do at this time. You'll notice here that I have a gap. I have a hole that I have to fill, so I'm going to fill that with XPS foam. And right now, I just have a temporary fill of steel wool to keep mice out. I put in some backer rod and some foam, and I'll further address that gap at a later date. Here you see the finished product. Obviously, I still have some tape to put on, but I'm waiting to put that on until I install that door. And then I also am waiting to put on that inside corner until I have a thicker tape for that side and some backer rod. I need to get some supplies before finishing it. But here you see I've installed a rubber flooring. This is a 3/4 inch rubber mat flooring. This is outside of my utility room footprint. This is my now garage. This is where I'm going to put my tools and my bike and anything that can be stored outside of the thermal envelope. And one last look with all of the rubber flooring installed and the zip system in place, and I'm already starting to put things in the garage for storage. Not too bad, actually. It's fully insulated. This is now the outside of my thermal and air barrier, and the zip system provides me with the air and thermal barrier that I need for the inside. Now back to the exterior. Now, before I start any major project like this, I always feel a fair amount of anxiety. You have to have your head on pretty straight before you start tearing off your siding. And unfortunately for me, I never really know exactly how I'm going to complete a project. I do all kinds of lists and I plan ahead and I design the project on paper and in my head, but you often run into problems that you couldn't anticipate. So you'll notice right away I uncovered one of the electrical outlets. That was on purpose. I wanted to make sure that I addressed the electrical in this addition first. So I mapped out where all the outlets were going to be, so I figured out how I was going to adjust the current electrical to fit my needs for after the renovation. One thing you'll notice about this addition is that the corners are all sheathed in OSB. This is done purposefully to give the addition itself strength. When they framed this addition, they didn't put in any diagonal lumber to hold the structure sturdy while they finished framing. Instead, they put on this sheathing, which keeps the building itself from falling over in the wind. A couple things to note here. As soon as I take off this corner sheathing, this structure is now vulnerable to the wind. It's very important that if you're going to take away structural integrity, that you plan that out accordingly. So in day one here, you'll see that I reestablish structural stability by putting a piece of sheathing in that corner. You'll notice that I'm not going to take off both corner pieces of OSB at the same time, because then it would be possible for this addition to fall over, especially if I get a high gust of wind. Now, with the side on the left being uninstalled, I'm going to make sure and keep the OSB on the right, and that's going to give this building structural integrity enough to stand up against the wind. Another thing to notice is that I spend a lot of time using my magnet to pick up loose nails and screws. As much as possible, you want to clean up after yourself as you go. The longer you wait, the more likely it'll be that whatever's on the ground, whatever dirt or debris, is going to start to become incorporated into the ground, and you don't want that. Here you'll see me rewiring this outlet. I'm doing this because I'm moving the outlet in order to bring it up to code and to better fit in the interior that I have designed for this addition. I'm going to be turning this addition, which is one big bedroom and a walk-in closet, into 2 bedrooms with 2 walk-in closets. Now, I did a little trick here in order to make room in the wiring for another outlet. I rewired it lower than it was before, which gave me plenty of wiring to add an outlet at that location. You see, I put a hole there and ran the wire through as a rough opening. Later on, I'll go into the addition and I'll add the outlet box and the outlet. Another thing you'll notice is that I'm removing all the fiberglass from between the studs. I'm also removing the paper. This was faced fiberglass, and that was to have an air barrier. Now, I have a dry to the inside strategy for this addition, which means I can't have a vapor and air barrier between the insulation and the drywall. That's actually the surface that it's going to be drying to. My new air and vapor barrier is going to be on the sheathing. It's going to be zip system sheathing. You'll see that in a moment, but I have to dry to the inside. So I took out all that fiberglass and I took out that face, and I'm now putting in wool. The wool also adds a higher R value and is a fire resistant product. It's a better product. It's a little bit extra work to take out the fiberglass and put in the wool, but to get the extra R value, I calculated that it would be worth the time. It's also worth noting here that I'm keeping all this fiberglass. I'm keeping it in bags, and I'm going to redistribute it back into the attic after I finish with this exterior construction. There's always somewhere you can put fiberglass, so it's not something you throw away generally. It's not something that I would resell generally, although I could, but there's always space in the attic to add more fiberglass. Now, as you watch me, you may notice that I look confused and that things are happening rather slowly. This is my first attempt at pulling out this window, and this is my first attempt at pulling the corner piece, the sheathing off. So it took me a lot of time and energy to figure out exactly how I was going to do that. Once I understand how this is all constructed and I have some experience, the next time I pull a window, the next time I pull a piece of sheathing, it takes much, much less time. Now, this window is nailed in place, and originally my goal was to try and pry it loose with either a hammer or a pry bar. Well, as it turns out, it was much easier to get a saw and use a metal blade to cut the nails out. So that's what I did here, and once I learned this, the window came out rather quickly. Another aspect of this window's installation, and therefore its demolition, was that it was held in place by the interior framing. The window had framing around the edges of it on the interior of this wall, and that framing was actually holding the window in place. So in order to remove the window, I first had to go inside and pry that framing loose. It's getting pretty late in the day and I'm going to be wrapping up shortly here, but there's a couple things to note as I do. I did not install a piece of wool into that corner, the far left corner there, and I'm going to have to do that later on. I didn't install it now because I didn't want to open an entire new bundle of wool and only install 2 pieces. I knew I'd be installing more wool later, so I waited. This is the zip system that I'm going to be using. As you can see, it's roughly 2.5 inches thick. This is the thickest zip you can get, and it just so happens that that's what I got. All of my materials are bought secondhand, and this is just what the guy had. Happened to be enough to do this entire edition, so I bought it. As a quick side note, some of you might be imagining how painful all of this work is. This is very difficult work. It's very rough on your back and your legs and your arms. It's very important that after you do work like this, you do as much recovery as possible. You get a lot of sleep each night, you drink a lot of water, eat healthy food, and I like to go to my athletic club and stretch. I do stretches pretty much every night. I also do a lot of work in a hot tub where I massage my muscles with the jets, and I do work in the steam room and in the sauna. It's very important that after you wind yourself up doing all this work and get fatigued and get sprained and get strained, that you go and do some maintenance on yourself. So if you have access to a gym or an athletic club, I highly recommend accessing those places so that you can adequately recover. However, there is no substitute for a cold beer and some ibuprofen at the end of the day. So I'm just wrapping up for the day. I put about 6 or 8 screws in each piece of zip system sheathing just to get them up, just to get them secure, and just to give the building some strength. I'm going to cover up these holes so that they don't get wet, and then that's the end of my workday. If you'd like a free energy efficiency consultation, please email me at paulspassivehouse@gmail.com.